Okay, so back on section 3.4, we're talking about the equivalent statements here. So just to remind you, in the last video where we stopped, we had some things that are just in the book that you need to be aware of, but when in doubt, you just make two truth tables, you compare the final answers. That's what proves that they're equivalent statements, that the truth values come out the same when you work it out. But here's some that just to have handy, and again, you can keep others as a running list, but De Morgan's law specifically, that one shows up, it seems like more often. De Morgan's law says when you negate something in parentheses, yes, you do distribute the negation, but a funny little rule is that flips. If it's an and, it changes to or vice versa. So you do flip the middle sign when you distribute the negative with our logic rules. Another one that shows up in the book is if P then Q is equivalent to not P or Q. It just is. We did that one in our first video. We did prove that. And then it is false that if P then Q, that is the same thing as P and not Q. And again, it just is. You can show it. All right, so you have an activity, number 3 and number 4. So again, if you haven't done those, please pause the video and do so. So the first one is just asking you to recognize, oh, I didn't draw that very pretty, asking you to recognize that that's the one we just wrote down. That is this last rule. So a not of the quantity P then Q is the same thing as P and not Q. Then the fourth one makes us take it a little bit farther and use the words. It says, it is false that if you hang the picture, then it will be crooked. So remember that phrase, it is false that. That's what we're doing up here. It is false that always means a negation of a parenthesis, and it's a if then. If you do something, then something. A if then statement. So that is, what we've been practicing there on 3. Now they want you to use it. It says, it is false that if you hang the picture, so we're assuming statement P is you hang the picture. If you want some words in there, we're going to need that to write our statement. And then Q, the picture will be crooked. Okay, so there's our P and Q statements. So this is saying it is false that if you hang the picture, then the picture will be crooked. An equivalent statement of that is our P and not Q. So let's write that out as an equivalent in words. P is if you hang the picture, or we don't use the word if here because it's just regular P, we'll say you hung the picture, or you did hang, I don't know how you want to say it. Let's say you hung the picture. And then and is our connective, and then you want to negate Q. The picture will not be crooked, and the picture will not be crooked. Those should be equivalent in our English language to saying the same thing, and kind of read those to yourself and see that you think that would be so. And the picture will not be crooked because we're negating Q. So again, always feel free to pause in the video and thinking about these things before going on. All right, so that's practice with some of the pre-formed equivalent statements to practice with that. The last thing in this section, we'll see at the bottom of the page, is different ways of writing the conditional or variations of the conditional. Variations of the conditional. The conditional is the if then, if P then Q. There's the conditional. All right, so just following along in the chart, we have 4 ways, 4 orderings of this. So the original conditional is a if P then Q. That's right, if P then Q. All right, the converse of the conditional. When we say the word converse, we're actually switching the order. We're saying if Q then P. So it switches the order, converse. The inverse of the conditional negates. It keeps the order, but it negates not P, not Q. If not P, then not Q. And then the last one is called the contrapositive, and it switches and negates. Contrapositive, I should say. The contrapositive does both. It switches the order and negates. So it'd be, of the original conditional, it will not Q, then not P. And you may be wondering, well, are these the same thing? Is it okay to switch the order? We'll talk about that. Or you could do a truth table and see, is it equivalent? So we'll talk about that though in the next statement. Is it logical to switch the order? Do you always get the same result? If you switch, if I say an if-then statement, is it okay to say it backwards? So, maybe not. But some of these, maybe they are okay. If you're curious, make those truth tables and compare your final answers. That's how you know that you know on it. That's how you prove it. But we will be talking about that further in the next chapter, what's logical to say, and which ones of these would be equivalent. All right, for now though, the activity is now practice using the conditional statement. If you get an A, then I will buy you a car. Do the 3 iterations of that we just talked about. So pause the video again. We've got an if-then statement. So if you get an A, don't you wish somebody would buy you a car? If you get an A, then I will buy you a car. I'm just dreaming here, All right, so that's the original conditional. If P, then Q is P is if you get an A. All right, so let's call P, statement P is you get an A. And statement 2, or Q, sorry, I will buy you a car. Buy you a car. I'll just shorten that. Okay, so we got if P, then Q is the original conditional. So now we want to do the converse, which we learned above. The converse switches the order. So it would be if Q, then P. In this case, if I buy you a car, if I buy you a car, then you will get an A. Now will you? Will that always happen? Then you will get an A. All right, so that would be the converse, switching the ordering. All right, then the inverse, so that's converse. The inverse negates each thing. The inverse is the negator. It would be keep the order P to Q, so not P, then not Q. So we want to negate each thing and say, if you do not get an A, then I will not buy a car. So you just negate each part. I won't take time to write that out because you can hear me, right? If you do not get an A, so you'll negate that, then I will not buy you a car. So negate each part. And then contrapositive does both. Negates and switches. So it does, instead of P then Q, it makes it not Q then not P. Switches the order and negates both. So that ordering would be negate, negate in the opposite order. So if I do not buy you a car, then you will not get an A. If I do not buy you a car, then you will not get an A. Something to that effect, negating and switching. And then the last one, again, you can pause, is practice for you. Another example, it's the same thing, but just more practice with this. So let's do it. It says write the 3 iterations of if you eat meat, eat your meat, then you can have your pudding. Then you can have pudding. So we've got a if P then Q. I would call statement P as it stands in its original form. If you eat your meat, eat the meat. And statement Q, have pudding. Alright, so we're going to do the 3 iterations of that, switching the order and the such. So in order, first one is converse. Converse is where we switch it up. Right now it's if P then Q. That's the original conditional. So switching the order would be Q then P. If Q then P. So that would be if you have your pudding, then you eat your meat. So switching this up. If you eat your pudding, if you have pudding, then you eat the meat. Inverse will negate each side, but keep the order. If P then Q, so keep the order, but negate P then not Q. So negating each part with the conditional in the same order. So that would be negate, if you do not eat your meat, then you do not have pudding. If you do not eat your meat, then you do not have pudding. Same order, but negating. And then contrapositive does both. Contrapositive negates and switches, so it would be not Q, then not P. So let's see, can we do that? Negating Q. If you do not have the pudding, then you did not eat the meat. And again, we'll explore further in the next section, and you can explore it now, really. You can find your answers. Are these equivalent? The way you know if something is equivalent, we would make a truth table for P, then Q, if P, then Q, then make a truth table for any one of these, and then compare. Do they have the same truth value? So keep that in mind. That's how you prove something. But we'll have some shortcut answers just like we've had in this in the next section. All right, so I hope that helps.